This is Mission Control, Houston. 73 days, 15 hours, 52 minutes into the 36th expedition to the International Space Station. Station is flying in good shape today, currently in an orbital nighttime pass, about 258 miles above Malaysia and Indonesia. The course will take it over the South China Sea and Taiwan, and then overfly Japan before another transit of the Pacific Ocean. On board right now, flight engineer Chris Cassidy is working in the Quest airlock module. He's continuing with troubleshooting of the spacesuit that Luca Parmitano was wearing during the spacewalk last week, the spacesuit that was leaking water into Parmitano's helmet. That troubleshooting's been going on since earlier this morning. Right now, Parmitano himself is involved with a routine periodic hearing assessment, while flight engineer Karen Nyberg is checking out the H-2 transfer vehicle hardware command panel. The other three members of the space station crew, Commander Pavel Vinogradov and flight engineers Alexander Mazurkin and Fyodor Yurchikhin, are off duty today in preparation for their work tomorrow to support the docking of the Progress cargo craft. Today's the 120th day in space for Vinogradov, Mazurkin, and Cassidy. It is the 59th day on this mission for Yurchikhin, Parmitano, and Nyberg.
And HCP checkout.
All six crew members were watching yesterday afternoon as they said goodbye to a Progress cargo ship that undocked from the station at 3:43 Houston time as the station was flying above eastern Kazakhstan. We've got a little video of that departure from yesterday that we can show you right now. The view from the Progress craft after the hooks and latches that were holding it to the Piers docking compartment disengaged and springs pushed it away. The Progress backed away from the station, conducted a separation burn, and about 2 orbits later completed a deorbit burn that set the ship on course for a destruction entering the atmosphere above the Pacific Ocean. That occurred about 4 hours after the undocking itself. The Piers docking compartment docking interface is now open, and the preparations are continuing to put another Russian cargo vehicle at that location. Preparations in work for the launch tomorrow of Progress number 52. That Progress vehicle was brought to the launch pad at the Baikonur Cosmodrome yesterday. It's carrying more than 2.5 tons of cargo. That's 1,212 pounds of propellant, 42 pounds of oxygen, 62 pounds of air, 926 pounds of water, and just shy of 3,400 pounds of a variety of other cargo, including spare parts, maintenance equipment, and experiment hardware. It's a view of the preparations of that Progress vehicle being loaded into the rail car for its trip to the launch pad at Baikonur. The movement out to the launch site, once again, that took place yesterday on Thursday. NASA TV will provide live coverage of the launch of the Progress vehicle. Our coverage will start at 3:30 Houston time tomorrow afternoon, before the launch at 3:45. This is another expedited mission of a Progress ship to the station, just a 4-orbit journey. The docking of the Progress 52 to the Piers docking compartment should take place about 9:26 Saturday night Houston time. The launch and the docking, of course, will be covered live on NASA television.
Houston Station 02 from the airlock.
Go ahead, Chris.
With what we learned today, will we be using any of the items that are being flown up on the Progress?
Potentially, Chris. Yes, you have there's a part coming up and some tools as well. And the forward look will certainly include information on how we're going to proceed forward. So the answer to your question is yes. And also, we got a lot of great data today. We wanted to, the team wanted to thank you and Karen, Luca, everybody that helped out getting things ready for today and helping us step through this procedure. It helped us. It helps us to narrow our search a little bit, and we did have some, although they're partial answers, they help in helping us determine exactly what's going on. So thank you. It's great work today, and really appreciate your patience on the timeline as we work through the blocks and monitored from the ground. So good work. We're actually, within the next hour or so, we're going to have a caucus and putting together exactly what we learned from today, and we'll have those words to you later in the day. So your DPC is a little less than 4 hours away. We hope to have words to you either before the DPC or during the DPC, what we learned today, and maybe some possible looking forward to what we'll be maybe doing sometime next week.
Okay, good luck. I know it's a lot to talk about.
Chris Cassidy, they're speaking with astronaut Doug Wheelock, who is at the Spacecraft Communicator console today, along with Robert Hanley, both of them seated next to Flight Director David Korth. Wheelock has been on console today to work with Chris Cassidy on the specific topic of the troubleshooting of Luca Parmitano's spacesuit from last week.
Wheels, one more go back.
Go ahead, Karen.
As I'm cleaning up here.
Yeah, I can.
Go ahead, Chris.
Do you need any of the washcloths that we soaked up the water with?
And it sounds like we don't, Chris. Thank you for being on standby to get those samples, but it sounds like we're pretty clean on those, and so we do not need to save any of that water.
All right, very good.
Nicely done, Chris, and looks like the airlock and the EMUs are in a good config, and you can go about the rest of your day.
During a spacewalk by Cassidy and Parmitano Tuesday of last week.
Okay, copy that. I'll just finish cleaning up here. If you need anything else, don't hesitate to call.
Copy that. Thanks, Chris.
An issue arose as Parmitano detected water inside his helmet on the back of his head. The quantity of that water increased, and the decision was made to end the spacewalk early in order to bring Parmitano back inside. Teams on the ground have been working since then trying to isolate the cause of that situation. The crew members last week looked over the suit and didn't find any smoking guns, as it were. This week they got a new set of procedures which Cassidy and Nyberg began executing earlier today, targeting specifically the spacesuit's condensate water relief valve, the water separator pitot tube, and the sublimator, the integrity of the sublimator in the suit. Throughout, there was some information gleaned, as you just heard, Doug Wheelock letting Cassidy know that they did get some information to point them in a direction, but no obvious solutions to that problem. Cassidy's now put the suit back together. The data will be studied some more by the folks here, the spacewalk specialists here in the Mission Control in Houston. The Expedition 36 crew on board the International Space Station has spent a week concentrating on a lot of laboratory science in a range of disciplines, all while taking care of the station and setting up for the going and coming of Russian cargo ships. On Monday, Commander Pavel Vinogradov began with the evaluation of his cardiovascular function during a series of progressively more strenuous exercises conducted on a stationary bicycle. That information is added to the studies that have been ongoing for some time, providing more data for scientists who are looking at the ways the human body is affected being in a weightless environment for an extended period. They're trying to find ways to counteract the bad effects so future explorers can stay healthy on longer missions. Vinogradov also spent time Monday then stowing items into the Progress 50 spacecraft in advance of its undocking on Thursday. Flight engineer Alexander Mazurkin spent part of his Monday on routine maintenance tasks in the Russian segment of the station, and the afternoon working along with flight engineer Fyodor Yurchikhin on a Russian experiment that's looking into new ways to identify the sources of depressurization inside a pressurized vehicle. The Russian crew members worked on that experiment, known as BAR, throughout most of the days of the week. Flight engineer Karen Nyberg started the week with Robonaut operations. She set up the R2 robot and the teleoperations equipment in the Destiny module, monitoring the commanding of tasks from the ground and directing the robot's actions with her own motions through the use of the instrumented gloves and goggles. The Robonaut is a testbed for evolving robotic operations in space. It is demonstrating what a robot can do and helping developers as they test the boundaries of what a robot might do in the future, including helping the human crew with tasks inside the station, perhaps someday outside the station as well. Flight engineer Luca Parmitano spent a good portion of his Monday in the European Space Agency's Columbus laboratory reinstalling the microscope and spectrophotometer in the BioLab, which had been removed for refurbishment back in 2011. This is the start of BioLab maintenance in advance of some advanced extended ground testing and commissioning to demonstrate that facility's ability to support some upcoming experiments looking into the effects of microgravity on biological organisms. Flight engineer Chris Cassidy set up the fluids integration rack for a physical sciences investigation called Advanced Colloids Experiment. It is the first in a series of microscopic imaging investigations of materials that contain colloidal particles. The investigators are looking into the flow characteristics and the ordering effects of those materials. On Tuesday, Vinogradov and Yurchikhin completed their refresher training on the Toru system. That's the system that allows a cosmonaut located in the Zvezda module to take over manual control of an approaching Progress cargo ship. That training in advance of the departure of 50P and the expected arrival of a new load of supplies that are targeted for launch from the Baikonur Cosmodrome on Saturday. Cassidy focused his maintenance attentions Tuesday on the science hardware, working on the Marangoni apparatus in the Kibo laboratory. That's an experiment into Marangoni convection that's designed to learn about heat transfer in microgravity. Parmitano took care of station maintenance that day, too, including a routine inspection of the portable fire extinguishers and breathing apparatuses. He did that in the morning. He also took time to speak with officials of the European Space European Space Industries. They were all gathered at the Altec Center in Italy to talk with him about the progress of his flight. The science started off the day for Parmitano on Wednesday as he initialized samples for runs in the binary colloidal alloy test experiment, while Karen Nyberg gathered up hardware and installed the centerline berthing camera in the window of the Nader hatch of Node 2. That's to support next month's arrival of the next H2 transfer vehicle. Then she joined with Parmitano and Cassidy for a conference with the spacewalk specialists in Houston as they reviewed the procedures for the next round of inspections designed to try to isolate the cause of last week's malfunction that allowed water to leak into Parmitano's helmet during a spacewalk. The hatch to the Progress vehicle attached to the Pirs module was closed on Wednesday morning. And on Thursday, Vinogradov and Yurchikhin had a conference with the team in Moscow to review procedures that they would follow in the event there was an issue, and crew members had to take over manual control to redock that vehicle. But there were no such issues, and 50P departed the space station on time on Thursday afternoon and was deorbited above the Pacific Ocean Thursday evening. Parmitano spent his Thursday morning in the combustion integrated rack, installing some new hardware components in the multi-user droplet combustion apparatus. That's in anticipation of the next set of combustion experiments. There are a few of those such experiments on board, all dedicated to learning the details about how different fuels burn when there's no gravity around. That's designed to improve fire safety as well as fire suppression techniques, but also to learn more about the efficiency of engines which use liquid fuels. Nyberg devoted part of her Thursday to preparing for next month's arrival of the H-2 transfer vehicle by checking out the HTV hardware control panel and then reviewing the procedures that she'll follow when she flies Canadarm2 to grapple HTV and berth it to the station's Harmony module. Later on, she joined Cassidy. The two of them talked about their mission in interviews with the Washington Post and the Portland, Maine Press Herald, the newspaper in Cassidy's home state. On Friday, the U.S. segment crew members concentrated on a number of maintenance tasks that included troubleshooting of the spacesuit Parmitano wore last week and which leaked water into his helmet. There were no obvious indications of the source of the problem that turned up yet. Parmitano prepared to command a robot on the ground in California. That's part of the Surface Telerobotics investigation, looking into how the human crew on board an orbiting vehicle can command robots, which are hundreds or even thousands of miles away on the surface of a planet or asteroid or the moon, in order to have those robots perform tasks that will help the people explore those places. The station's Russian crew members were all off duty on Friday, since they'll be working all day Saturday to support the arrival of the new Progress vehicle. 52 Progress is to launch from the Baikonur Cosmodrome at 3:45 p.m. Saturday Houston time and dock to the station's Pirs module less than 6 hours, just before 9:30 p.m. the same day. The Expedition 36 crew is getting set to execute the second space-based test of a system to permit control of a rover on the ground by a crew member on board an orbiting spacecraft. For today, it's flight engineer Luca Parmitano, who will be at the station's controls, commanding the activity of a rover called K-10, located at the NASA Ames Research Center in Moffett Field, California. The investigation is called Surface Telerobotics. And earlier, I spoke with the payload developer, Maria Boilat, at Ames, about today's operation and the results they got from the first experiment run last month. Well, Maria, remind us what Surface Telerobotics is all about. What's your goal here?
Surface Telerobotics is an engineering test of a mission concept. So in this concept, crew in a vehicle that's either orbiting, say, the moon or Mars, or perhaps approaching a planetary body, let's say an asteroid, would control a robot on the surface. So this is an idea that's been proposed in several human exploration architectures, and what we're trying to do is test the concept, see what sorts of technologies are needed in order to realize it. One of the hardest parts of any planetary mission is safely landing on the surface, and a robot that's on the surface and controlled by crew that's orbiting or approaching can get a lot of the sort of precursor exploration work done. So, for example, a robot could be used to help prepare a landing site to make that surface landing simpler. For example, scouting out a clear area, checking whether the ground is firm, also possibly even building a landing strip to prepare for humans.
That all seems very reasonable, but it also begs a question about why is this so hard? I mean, I see kids in the park flying remotely controlled airplanes, but you got some other issues to deal with.
Yes, well, for one thing, the kids controlling RC airplanes are looking directly at the airplane, so their response and their feedback to that control is very immediate. Whereas a crew member in an approaching vehicle or an orbiting vehicle will have some communication delays. There are still some pretty vast distances between where the robot is and where the crew is. And so those delays, even if it's just a few seconds, can make controlling a robot very difficult. It can make joysticking, for example, hard to do because you need so much higher level of concentration in order to perform that task. So what we're doing is called supervisory control, where our robot is pretty smart. It can perform a variety of tasks. It can keep itself safe. And so the astronaut will actually send a sequence of tasks for the robot to do and just monitor how it's doing its job, making sure it's doing it correctly. So then if the robot has any difficulty, gets into trouble, he can step in with manual control.
Now, you've done this once before with Chris Cassidy in June. How did that one go?
That went really well. We were very happy with how that went. Chris managed to pick up how to control the robot very easily. So he completed not only the first phase of our simulated mission, but was able to continue on and get ahead of schedule and start deploying a telescope. So we did have one slight hardware hiccup towards the end of the session where our deployment device had a little hiccup, and so we think we fixed that for this next session with Luca.
You mentioned that he picked up on how to control a robot. How does the astronaut control a robot? What's the interface? What do they use?
So as I mentioned, joysticking is very difficult in this situation. So what we use is a graphical user interface, or GUI. It's running on a laptop on board the station, and Luca will see images from the robot's cameras. He'll see 3D renderings of the robot and its surrounding terrain, and then he'll use button presses basically to control the robot when he's taking over manual control. He'll be able to send fairly simple commands. So, for example, drive forward 1 meter, or rotate 15 degrees to the right, or take an image. And so those are, fairly low-level commands that he can do manually. For the most part, though, he'll be just uploading basically task plans to the robot. So the robot will run its tasks autonomously, and he'll step in just when needed.
In terms of this experiment, what are the objectives now? I think you said that you're really picking up on the same simulation that you started with the first session.
That's right. So our simulated mission is to deploy a radio telescope on the far side of the moon. So the idea is that crew either orbiting the moon or the L2 Lagrange point on the far side of the moon could control a robot on the far side that doesn't have direct line of sight to the Earth. And would deploy a radio telescope. So this radio telescope would be used to look at the cosmic dawn. So this is it's after the Big Bang when the first stars and the first galaxies were forming. So in the first session, Chris performed what was basically scouting of the site. So we've had orbital data of the site, and we have an idea of where we want to deploy the telescope. And so first we need to send the robot around to make sure that that area is actually clear for deployment. So the second part that we're going to do today that Luca will be performing is the actual deployment of the telescope. So the telescope's made up of 3 arms, and the arms are long strips of Kapton film. And for an actual radio telescope, the antennas would be embedded in the Kapton film. For our test, it's just the film. We're not actually deploying a working radio telescope. And so the robot will actually spool out these rolls of Kapton film.
You didn't just happen to have a spare radio telescope laying around.
No. Yeah, that's pretty complicated. And for our purposes, we're looking at the rover's job, not the radio telescope's job. So it's fine that there aren't actual antennas in the Kapton.
And in this case, it's again a planned sequence of movements
That's
rather than just Luca indulging himself.
Yes. So the robot's going to spool out, each of the antenna arrays, and he's going to monitor to make sure that there aren't any kinks and that the robot's, doing it properly. Also, we'll be taking images as we deploy to make sure that there are no tears in the film, and that it's all going according to plan. And then he can take over manual control if it isn't.
Assuming this goes as you have planned, what's the next step? Are there more similar sessions with this crew?
Yes, we're going to have one more test session next month with the crew of Expedition 36. So we haven't been assigned our crew member yet, so perhaps if we get Karen Nyberg, we'll have a trifecta of Expedition 36. And then after that, we'll look at our data to determine how well our systems worked, where we can improve, where are the gaps in the current technology. So what technologies do we need to develop in order to have this mission concept work? And then K10, our little robot, is slated to do some science field work in the Mojave Desert next year.
And that be part of this experiment as well?
It's a different project. It's similar work to what you would use the robot for on the ground, but we won't be using crew members to control it.
All right. Maria, thank you very much for the update, and good luck with today's experiment.
Thank you.
Maria Boilat is the payload developer and project technical lead for the Surface Telerobotics investigation at NASA's Ames Research Center in California. And this is a live view out at Ames at the Roverscape, where K10 is standing by, ready to perform in today's operations. Maria Boilat is scheduled to have a pre-experiment run conference with Luca Parmitano coming up in just about a minute, and their operations set to begin at about 10:45. This is a live view on the exterior of the International Space Station right now, where the Canadarm2 is attached to the Destiny Laboratory. The current view is, well, upside down, if you will. You can see the Earth, which is below the station, is above it in this view. Robotics operators are reporting to Flight Director David Korth the status of the robotic arm. They had also moved the special purpose dexterous manipulator.
Also station Luca on 3.
Over on 3, Luca.
Yeah, let me know when you're ready to start the briefing.
We are ready whenever you are.
Let's start.
Okay, I have Maria Bualit standing by, and she is ready for your conference.
Welcome on board. I'm all ears.
Good afternoon, Luca. Good afternoon. So first off, we'd like to verify that you've been able to review all of our documentation, so the big picture words and the help.
Yeah, I used all the time that you guys gave me. I started actually last night since I had it on board, and then today I finished up. I also talked to Chris before doing my training session.
That's great. So do you have any questions, either about the GUI or the references?
I really couldn't come up with any questions. I think that some may show up while we do it, but I think I have a pretty good idea. I think that the material that you sent up is pretty good. Actually, it's excellent, and so I'm just excited to work with you guys.
Okay, great. I know that you had a question on whether or not you could take some photos to send on to the Meteron.
Yeah, ESA, the European Space Agency, is doing right now a robotics competition, and I'm sort of the host of this robotics competition. And I thought it'd be cool if I could just send a message down saying, hey, I'm working with a robot that I'm commanding from the station on the ground. I thought it'd be cool, but I totally understand if it's proprietary, and no is a perfectly understandable answer, and I was just asking if it can be done.
Feel free to take any photos you like. In fact, we'd like copies.
That's awesome. Thank you very much. I bet ESA people will be very excited. Thanks.
Sure. I also want to let you know that we actually have a couple of Meteron representatives here in our mission control at.
Okay, I only understand that you have somebody in mission control, but you got cut off. I think that the communication is coming broken. Maybe you're releasing the button too early. I only heard the middle of your sentence.
Okay, sorry about that. I just mentioned that we have some ESA Meteron folks here at our mission control at Ames.
Oh, that is awesome, and Welcome on board to them too. Wonderful.
Okay, down to business. We have some useful tips for you to help with our ops this afternoon. So I'll start with panoramas. The success of a panorama depends on capturing the intended targets in the image, and that is described in the panorama.
Okay, I copy.
Okay, we ask that you monitor the hazard camera during drive, so look out for obstacles. Also, if you encounter an obstacle that the rover seems to have difficulty getting around, you may need to back away from it manually because the rover navigation software won't move back.
Yeah, and Chris was actually telling me about that, and so I'm totally ready to fly this thing a little bit around. As a pilot, I'm very excited about trying that.
Okay, that's great that you've been able to talk to Chris about it. Some additional information, skipping steps. So if you're resuming a plan and need to skip ahead, skipping is a little bit slow. So, for instance, when you get around the obstacle and you restart the plan and need to skip ahead, just have some. Also, today we're going to be deploying the antennas of the telescope. And during deployment, you may see some people moving around in the camera view, say in the inspection image, and you can just safely ignore that. Also, there'll be some striped bars put on the film to weight it against the wind since we aren't actually on the moon. And it'll also show you progress. You'll be able to see that the stripes are moving around, and so that'll let you know that it's a new. In addition to that, we're going to have a delay between deployment of the arm. So after an arm deployment is completed, we need to reload a new roll of film. So once the final inspection image comes on, we're going to have somebody on the ground who's going to e-stop the robot, and then we're going to put in the new roll of film. So just wait for a go-ahead to proceed after an arm.
Okay, and Maria, you're still coming in broken at times. I don't know if it's a comm problem or a mic problem, but I'm missing about 10% of what you're saying. I still understood all of your instructions. And I do have a question about skipping.
Okay, go ahead with your question.
Okay, so my question is, if the robot stops at one point, and I want to continue, so I back away, I go around it, I want to go to the next stage. Can I skip and give an order to just continue to the next base, or do I have to drive it all the way in order to finish that?
If the robot fails the drive task, so it gets stuck behind an object, and you need to, drive around that obstacle, then you'll have to reload that plan and then skip ahead to your new destination.
So what I'm saying, make sure that we are on the same page. What I'm saying is, after I drive around the obstacle, I don't have to drive it manually to the next objective. Is that correct, or am I understanding you wrong?
No, that's a correct understanding. What you need to do is reload the plan and then tell the robot to go to the next destination by skipping the steps that were already completed before it got stuck at the obstacle.
Okay, perfect. Copy all. And I don't have any other questions. I would suggest that we start early so that we can get more objectives completed.
Okay, copy that. Sort of a clarification, you don't need to reload the plan, but you may need to skip to the goal that you're trying.
Okay, we'll make sure that remember that if it happens, I'll solve it there and then. And how do you like the video feed right now?
That's looking really good. Just a request to possibly move the cable that's in front of the screen. That looks great, Luca. One other thing, we are going to actually restart the workbench between our phases. So we'll do phase 2 and restart the workbench, and then phase 3. Also, we'll restart it right now from between training and. Copy that. Just one last tip. When we're asking you to fill out the questionnaire, please don't refer back to the UI because we want to look at your situation.
Okay, and the questionnaire will be, where would it be?
The questionnaire is on SSC 9. It's on the P drive. And we'll be reading up instructions of the file name to save it to and which pages to fill.
Okay, Maria, I just one more request for you. It's to wait a couple potatoes before releasing the button at the end of your sentence, because I have the impression that maybe you are releasing the button too early, and so I don't get the end of your sentence.
Station Huntsville on 3.
I apologize.
This is Paycom. Luca and Maria, would you guys move to 2? I think you'll have a little bit better time hearing each other.
Answer station, Luca. I'm happy to move on to.
Copy, thanks.
And I'm moving over.
Station rover up.
Go ahead.
Okay, just want to make sure that we answered all your questions.
Our session, I'm ready to start, and yes, you answered all my questions.
Okay, great. We're going to restart the workbench to clear all the footprints from the rover, and then we'll get.
You're looking at a live view of the K-10 rover on the ground at NASA's Ames Research Center in California. Luca Parmitano is on board the space station, set up at this worksite, and he is about ready to start sending commands to that rover. This is part of the Surface Telerobotics experiment. The second session conducted during Expedition 36. Chris Cassidy was the crew member on board during the first one. We're going to see Parmitano issue commands, and we will be able to switch to that live view at Ames and see the result of those commands. This session with the Surface Telerobotics is on the schedule for 2 hours, and we'll be able to show you what it looks like here for the next 10 to 15 minutes or so during our broadcast this morning. While Parmitano is doing this work, his crewmates are involved in a couple of other activities. Flight engineer Karen Nyberg is scheduled for her exercise workout on the Advanced Resistive Exercise device right now, while Alexander Mazurkin is running on the BD2 treadmill in the Zvezda module. Mazurkin, Pavel Vinogradov, and Fyodor Yurchikhin all off duty today. They have been doing their exercises, of course, and taking care of some state maintenance in the Russian segment of the space station.
I'm waiting for your go. Load the sequence and the task, and I'm ready whenever you are.
Stand by, Luca. Let me check on that for you.
Luca, this is Maria. Your go to proceed.
Copy.
As this test proceeds today, you can expect to hear Luca Parmitano. He'll be talking with the Surface Telerobotics payload developer, Maria Boilat, who is on the ground at Ames. And this is a live view from what's known as the Roverscape at NASA's Ames Research Center in Moffett Field, California. Getting a look at the rover as it moves around that area in response to the commands that are being sent right now by Luca Parmitano on board the International Space Station. In the course of this test today, we should see the K-10 robot deploying some Kapton film that is meant to represent a radio antenna on the far side of the moon. This is part of an ongoing simulation that began with Chris Cassidy's session on this last month. The robot is moving under the interactive remote control of an astronaut who, in the case of this simulation, is at the L2 Lagrange point 40,000 miles away from the surface of the moon. Once again, that film that the robot is deploying is representative of the arms of the radio telescope. For reference's sake, the robot here, K-10, is about 4.5 feet tall. It weighs 220 pounds and drives and steers with its 4 wheels. Its speed is about 3 feet per second, which is just a little slower than the average person walks. For the purposes of this test today, K-10 is equipped with several cameras as well as a 3D scanning laser system to perform survey work, and the mechanism that's used to deploy the simulated radio antenna, which we see in operation now. As we heard Maria Boilat explain to Luca Parmitano in their conference ahead of time, the strips that that gentleman is laying down on the Kapton are there simply to hold it in place in case of the wind at this location. They're not part of the actual antenna and wouldn't be necessary on the surface of the moon because there would be no wind. This test is simulating a possible future mission that would involve astronauts on board Orion that would travel to the L2 Earth-Moon Lagrange point, which is 40,000 miles above the other side of the moon, the point in space where the gravity of Earth and the moon balance out, and the spacecraft could hold a stationary orbit. In this scenario, from that location, the astronauts could operate the robot remotely to perform the science work, to deploy a radio telescope that would then work from that location pointed out into space. The primary objective of the overall project, the K-10 rover project, is to understand how an advanced and remotely operated robot can improve astronaut safety, can enhance science activities, and increase mission success, in the process reducing the cost and risk to the astronauts and the use of consumables like fuel and oxygen. Luca Parmitano, on board the International Space Station, is commanding that K-10 robot on the ground in California. For the purposes of today's demonstration, he's going through a program sequence of tasks in order to deploy this simulated radio telescope. Looking ahead, there is a third operation for this experiment with the Expedition 36 crew that is expected to take place in August, that will continue and complete the simulated mission that we're undergoing today.
Station Huntsville on Space to Ground 2 for Luca. We'd like to ask you to pause now for a questionnaire.
Okay, I'm ready. I can see that the robot is disconnected and ready to navigate to the questionnaire.
Stand by, Luca. We'll figure out how to do that for you.
And while Parmitano continues to do his work with the Surface Telerobotics, we'll let you know that coming up tomorrow on the International Space Station, the U.S. crew members are going to have time for their regular housekeeping, but then be off duty. All of the crew members will be paying attention later in the day yesterday as a new Progress vehicle loaded with supplies is due to arrive at the International Space Station. Our NASA TV coverage of the launch of Progress will start at 3:30 tomorrow afternoon for a 3:45 docking, and we'll be back at 8:45 Houston time on Saturday night for coverage of the docking of Progress 52. That docking is anticipated to take place tomorrow night, 9:26 p.m. Houston time.
So for Luca on 2.
Coming up next on NASA television at the top of the hour, 11 a.m. Central, we'll have today's NASA TV video file, which will include features on the Surface Robotics test operation that Luca Parmitano is involved with now, as well as yesterday's departure of a Progress supply ship and other news from around America's space agency. NASA TV video file is at 11 a.m. Central, and our next live daily report on space station activities will be coming up for a Progress launch tomorrow from the Baikonur Cosmodrome in Kazakhstan. At a mission elapsed time of 73 days, 16 hours, and 50 minutes into Expedition 36, this is Mission Control, Houston.